What IP provides is what's called best effort packet delivery, meaning the routers will try to get it there if they can, but no promises. Okay? So what this means from the perspective of applications is you might not want to use IP directly. IP isn't enough. Packets could be lost along the way. Like if a router gets overworked, it might drop the packet. Or if there's a bit error in transmission, the packet might get dropped, and then it's just lost. And there's nothing when a packet is dropped or lost, there's no message back to the sender saying, hey, your packet didn't make it. It just evaporates and is gone, and no one has any idea. Okay? Packets might also be corrupted. Data might be modified in transit, and then the recipient, when they notice the checksum is wrong, will drop it. So that's kind of like a packet getting lost. And also, they might be delivered out of order. If I send a packet and then another packet, it can happen that actually they arrive at the recipient in the opposite order. And that might sound crazy, like how could that happen? But to give you some idea, if I send multiple packets, there's actually no guarantee they all go through the same path through the network. They might take different paths. So it might be that path changes partway through, and maybe the new path was faster. The network learned a faster way to get there. And the first packet, it only knew the slow way. And by the time it got to the second packet, now it learned the fast way, and the second packet actually arrives there quicker. So you've got to be prepared for that. So you wouldn't want to write your applications using only IP as your only tool you had available to you. Yep. What's the point of having a source address? It's only for the benefit of the destination. So the destination can know who sent this message. Like if the destination wants to reply or respond, then respond back to that source address. Like when you send someone a letter, you put an address on there. Well, when I send a letter through the postal mail, it's partly for the mail service so that if it can't be delivered, they can send it back to me. That has no analogy in IP. But the other reason I put it on there is when I send a letter to someone, if they want to write back to me, they can look on the envelope for that address there. That's the reason why it's there in IP. All right, so this whole best effort thing sucks, right? I mean, it's just not what we'd really want. So that means that's why we have another layer. That's why we have the transport layer. It's the transport layer's job to make up for this suckiness provided by the IP protocol. Okay? So that naturally leads me to telling you about how transport layer works on the internet. And at this point, let me say that there's multiple protocols. The two primary ones are TCP and UDP. And by far, the most commonly used one is TCP. And what TCP does is makes up for all those deficiencies. It provides reliability in case packets get lost, they'll be retransmitted so that no matter what, your data will get there. It deals with reordering so that no matter what, the data will get there in the right order. It takes care of connections so that you can have a long-lived connection and it can be a two-way message stream.